Hello and welcome. In this video, I will be talking about current. Current can be observed as a bolt of lightning. Lightning is made up of charged air particles and electrons flowing through the air between the storm clouds and the ground. It is the flow of electrons or the flow of the charged air particles that is the current. When we first learned science, we said that current is the flow of electricity along a wire or through something. So in the case of the lightning, it is through the air. The word current comes from the Latin currens, which means running. More specifically, an electric current is the flow of electrical charge through a conductor. If that conductor is metal, then the flow of charge is the flow of electrons. At A level, we say current is the rate of flow of electrons. Rate is how fast something happens. In the previous video on charge, we said that electrons have a charge. So if current is the rate of flow of electrons, and each electron has the same charge, then current is essentially the rate of flow of charge. If we use the letter I to represent current measured in amps and the letter Q to represent charge measured in coulombs and T to represent time measured in seconds, we can say that I equals Q over T, or current is equal to charge over time. We can also use the Greek symbol delta, which looks like a triangle, to represent change. So we can say that current is the change in charge divided by the change in time. And for those students that also do A-level mathematics, we can say that current is the rate of change of charge with respect to time, dq dt. We measure current in amps, and 1 amp is defined as 1 coulomb of charge passing a point in 1 second, or 1 amp equals 1 coulomb divided by 1 second. Now let's look at some examples of current. Imagine a bowl of soup is heated in a microwave for 5 minutes and the microwave draws 3 amps of current. What is the charge that passes through the microwave whilst heating the soup? Well, we've already said that current is the rate of change of charge, dq dt, or more simply, if you like, current is equal to charge divided by time. We can rearrange this formula so that charge is equal to current times time. So charge will equal the current, 3 amps, times 5 minutes. But if you remember, we said that time, when we use this formula, the time is measured in seconds. So we convert that minutes to seconds by multiplying by 60 seconds. So overall, it becomes charge is equal to 3 amps times 5 minutes times 60 seconds. There's a clear conversion of time there from minutes to seconds. Overall, the charge is equal to 900 coulombs. We could also find the number of electrons that have passed through to the microwave too. Now, the charge on an electron, which I've represented here as Q subscript E, that is equal to 1.6 times 10 to the minus 19 coulombs. So the number of electrons would be the charge that has passed to the microwave divided by the charge on one of those electrons. So that would be 900 divided by 1.6 times 10 to the minus 19. and that is equal to 5.6 times 10 to the 21 electrons. And this is the number of electrons that have passed to the microwave. Since only whole electrons can either be added or removed from an object, the charge of that object must be some multiple of the charge of an electron, i.e. the charge will always be some multiple of 1.6 times 10 to the minus 19. Now let's look at another example. A battery is described as having an energy of 40 amp hours by the manufacturer. What does this mean? We sometimes see the words amp hours written as capital A space lowercase h. AH can be thought of as amps, which is of course the measure of current, multiplied by the time in hours. Remember, if we multiply a current by a time, we get the charge. So when the battery is described as having an energy of 40 amp hours, from a physics point of view, this statement is incorrect. What the manufacturers of the battery actually mean to say is the battery has a charge of 40 amp hours. So the battery has a charge of 40 amp hours. If we were to measure the charge of the battery in coulombs, we would use Q equals IT again. So that would be Q is equal to current, 40 amps, times the time, which would be 1 hour, times 60 minutes to convert it to minutes, times 60 seconds to convert it to seconds. So you can clearly see here, we're converting time from hours to minutes, then to seconds. So the charge would be 40 times 1 times 60 times 60. This would give us a total charge of 144,000 coulombs. Imagine now we wanted to work out how many electrons this is. Again, we would take our charge of 144,000 coulombs and divide that by the charge on a single electron, Q over QE. When we do this, when we do the 144,000 and we divide it by 1.6 times 10 to the minus 19, we obtain 9 times 10 to the 23 electrons. So far, I've only talked about the charge on electrons. And if I were to talk about the charge on, say, an aluminium ion, the charge would be different. Aluminium ions are Al3+. That is to say, they have lost 3 electrons. Therefore, the charge in coulombs of an aluminium ion that is moving, or no, it's just its charge, would be 3 times 1.6 times 10 to the minus 19, which is equal to 4.8 times 10 to the minus 19 coulombs. If we were talking about the current caused by the flow of aluminium ions, we would need to take care and consider that the charge flowing is 3 times more than if it were electrons flowing, because the aluminiums have lost 3 electrons. Therefore, consideration must be given to the size of the charge on the ion when we calculate current for its movement. Hopefully, this will give you a comprehensive understanding of charge as applied to the movement of electrons and ions. Just remember that current is the rate of flow of charge, or how fast charge flows. Thanks for watching. Please like and subscribe below, and goodbye for now. See you later. Bye.